Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn about all of the latest tools, patterns, and practices that power data engineering projects across every domain. Now there's a book that captures the foundational lessons and principles that underlie everything that you hear about here. I'm happy to announce I collected wisdom from the community to help you in your journey as a data engineer and worked with O'Reilly to publish it as 97 Things Every Data Engineer Should Know. Go to dataengineeringpodcast.com/97things today to get your copy. Your host is Tobias Macy, and today I'm interviewing Adam Wilson about Trifacta, a platform for modern data workers to assess quality, transform, and automate data pipelines. So, Adam, can you start by introducing yourself?
Sure, thanks. It's great to be here. Thanks for having me. My name is Adam Wilson. I'm the CEO of Trifacta, and I've spent my entire career in data integration, data transformation, data cleansing. Most notably, before taking on the CEO job at Trifacta, I had a variety of executive management roles at Informatica over a 13-year career. And I've been at Trifacta for the last 7 years as a CEO, being part of what's new and what's next in the category.
And do you remember how you first got involved in data management?
Yeah, interestingly, I had co-founded a company called Zimba. This was back during the dot-com boom. And the focus of that company was mobilizing dashboards. So you kind of have to wind the tape back a little bit and think about mobile in the early days of WAP phones, Windows CE devices, Palm Pilots. And there were a line of business managers and executives that were trying to deliver analytic information to different form factors so they could get their dashboards and their analysis on the go. So that was the idea behind Zimba. And ultimately, that company was acquired in August of 2000 by Informatica. And at the time, Informatica was looking to vertically integrate the BI and the data warehousing stack to create, business intelligence in a box. So you could go all the way from all the traditional ETL all the way through to prepackaged analytics that would then be delivered out to web, wireless, and even at that time, voice recognition interfaces. So it was a brave new world back then. Subsequently ended up running product management for the core data integration offerings, then product management, product marketing, and then a variety of general management roles as the company grew and formed business units through a number of acquisitions that were done over the years. And then ultimately, when Informatica was taken private, a number of us who'd really taken the company from IPO to about $1 billion in revenue decided it was a great time to jump out and take leadership roles in the next generation of what was going to be happening in ETL, data integration, data quality. And that's what led me to Trifacta.
Yeah, I definitely remember the days of mobile web being a distinct thing from the regular web. And I'm definitely glad to see that has gone away.
Nobody's having to write CHTML anymore and things like that.
Yeah, I think I still have some books somewhere, either in my bookshelf or ebooks, that are like, how to build for the mobile web. And I'm never going to read that.
That's right. Yeah.
Awesome. And so, as you mentioned, you are at Trifacta now, and I'm wondering if you can just give a bit of an overview about what it is that you're building there and some of the story behind the company.
So Trifacta actually started as a joint research project between Berkeley and Stanford. So you had a world-renowned database professor at Cal named Joe Hellerstein, who got together with a world-renowned visualization professor at Stanford named Jeff Heer. The two of them kind of came to the conclusion that a lot of the action, a lot of the pain, the cost, the time in any project was actually not in the compute or in the viz, but rather was in how do you take raw data and refine it. And as they studied that problem more carefully, they bumped into a grad student named Sean Candell, who had started his career as a quant at the Citadel in Chicago. And he had decided to go back to grad school because he was spending time, on working on the algorithmic trading, but really was spending most of his time, doing data preparation work. And he said, this is crazy. You've got all these high-powered data scientists who are all sitting around, and rather than doing algorithmic work, they're all cleansing and standardizing, shaping and structuring data. And he said, this would be kind of an interesting problem to go back and to, sort of study more carefully. So when he went to grad school, he joined up with these two professors who were doing research in this area. And at the time, their hypothesis was that the reason this is still so hard and so complicated and so expensive is because the people who know the data best are often not in a position to do the work. That, unfortunately, a lot of the work around data engineering has become the exclusive purview of the highly technical. And while those people may understand how to do structured programming and they may understand the details of how, data warehouses work, they often will lack context in terms of how does the data actually get used to make business decisions down the line? So they said, maybe it would be possible for us to democratize this a bit, to create, essentially a solution that would learn from the data and would learn from how the user interacts with the data in order to make intelligent recommendations and suggestions, and in order to, clean up or automate some of the more complicated things that people typically bump into. They created a prototype for this that really made it much more of a user experience problem. And within 6 months, they had 50,000 people using it. And that prototype was called Stanford Data Wrangler. And they actually picked Data Wrangler as the name because that was the vernacular of the user didn't think of their problem as an ETL problem. That was a more technical term. They really thought of their problem as sort of a problem of wrangling or munging or stitching data together. They launched this solution, and it was wildly popular. And that's when our good friends at Excel Partners and Greylock and Ignition and a number of other tier one VCs came knocking and said, hey guys, we think there's like a real company here, not just an academic prototype. So why don't you take sabbaticals and jump in and do this thing for real? So that was almost 9 years ago that this was pulled off campus. And, I'm sure we'll get into it as we go, but if you then sort of fast forward to where we are today, over 10,000 companies using the product in some way, shape, or form, and significant, customers out there like the Bank of Americas, the GlaxoSmithKlines, the Pepsis, as well as small, startups and consultants and pretty much anything under the sun in terms of types of users that are creating next generation data products using this no code, low code approach to the data engineering.
And I think it's interesting that you very deliberately use the term data wrangling pretty much everywhere across the site and in the different materials that I've seen versus the ETL that data engineers will be familiar with. And you kind of touched on the reasoning behind that, but I'm wondering if you can just dig a bit more into how that difference in terminology influences the way that you think about the problem that you're solving and the way that you design the product for, this data wrangling versus the more formalized ELT approach.
And you make a great point there, because that is something that we talk a lot about. And there's been an evolution, I think, in our thinking over time. So in the beginning, it was very much, eyes on data all the time. So one of the fundamental principles was that, rather than writing, specifications and handing it to somebody, and then hoping that some number of months or quarters later, they would generate a data warehouse and you'd finally get to look at the data. And then you'd be like, now that I see the data, it's not really what I wanted. Or now that I see the data, my questions have changed. The idea was that you would essentially interactively build a specification that was essentially, able to be put into production when you were done. So the idea was to do in clicks what used to take, months under the old model. The hope was that you're going to allow data analysts who, again, have a lot of context in their heads, more fully participate in this process. Was a lot about the original approach. And the original approach, I would say, was more of a no-code approach than even a no-code, low-code approach, which has become, which people talk about a lot these days. But we've seen that evolution ourselves, and that, as these projects spun up, the surprise for us was that as much as we wanted to democratize the ELT or the ETL work, we had to recognize that providing affordances for the traditional data engineers that would allow them to come in and to write code where necessary was going to be important. And a lot of that had to do with the fact that as you started thinking about operationalizing at scale, as you started thinking about governance, as you started thinking about how the scaffolding was going to be put in place to do this in a way that would be, applicable across an entire enterprise, pretty quickly you had to make sure that self-service wasn't going to turn into chaos. And it wasn't just going to be, well, let's let end users kind of go then do whatever they want. It really became more about this collaborative curation that was going to happen between the more technical users and the users that were very data-driven and data savvy, but not necessarily, again, structured programmers. And so over the last, roughly 9 years, we've evolved the platform quite a bit to embrace both sides of that equation, and to say that, we do need to make sure that we're thinking as much about the governance and operationalization. We're thinking as much about some of the complex use cases where writing code is going to be required, and to provide affordances for that, embrace and welcome that, into the process, while at the same time staying pretty committed to this idea that we do want a very visual experience, where people can go in and do this work very quickly without necessarily, having to be a, full-on, computer scientist. If they know a little bit of SQL, great. If they know a little bit of Python, fantastic. That's a bonus. But you don't have to be somebody who, is a more traditionally, trained developer in order to get productive with data. And we felt like that was really critical because in the end, for the last decade, everybody's being told, be more data-driven. And it's like, well, great. Well, then give me the damn data in a form that I can use it, and I'm happy to be. But don't tell me to be more data-driven, and then tell me it's going to take 6 months, to generate a data warehouse for me to actually start to make use of this information. So that was really the fundamental bottleneck that we were trying to, blow up through this process of the data engineers now finally coming together to work with, some of the analytic end users or analysts.
In the past 9 years, there's been a pretty huge shift in the overall landscape of data tools and the roles and responsibilities that exist across them. One of the most notable in terms of the role shifts is the idea of the analytics engineer that has come about because of tools like dbt. And then also on the platform side, things like cloud data warehouses have drastically accelerated the ability for people to spin up new locations for data and increase the availability and increase the flexibility of how that data is processed. And I'm wondering how that has influenced the ways that you have implemented the Trifacta product, and just any sort of new capabilities that you've been able to bring about because of this shift in the overall landscape.
There's been no more kind of fun time probably in the history of the world as it relates to data than right now. I mean, there's like Cambrian explosion of new technologies, new platforms, new databases, new architectures, new approaches. And for us, that's quite exciting because, in many respects, Trifacta is a decision you make that guarantees your other decisions are changeable. And what I mean by that is, we're not married to a specific storage architecture. We're not married to a specific execution environment or cloud platform. This is, polyglot approach that allows you to compile down to whatever makes the most sense. You can take your recipes that you create as you're doing your data wrangling and compile down to whatever makes sense for the workload or the use case that you're going after. And so I think as these new trends evolve and emerge, it gives us a chance to grab onto them as they start to mainstream. So you mentioned dbt. So, we've been doing some work with Tristan and his team, and, our very low code, no code approach is very complementary to what they're doing that's a bit more at the command line or at sort of more traditional kind of SQL programming. And, we get an opportunity to say, hey, wouldn't it be great if if you like DBT, so do we. And, we can actually take the SQL that we compile down to, which is one of the executions that we support, and we could actually generate DBT specific SQL. And we could actually help you profile what you're doing in and around DBT. And we could actually help you orchestrate some of what you're doing in and around DBT, but to do it in, again, a very visual way. And that is complementary to what we've historically done around things like Spark and things around data flow with Google. And even more recently, some things we've released where you can compile down to Python and, use Jupyter notebooks with Trifacta. And so this whole idea that, as these trends come on board, I think, for a lot of our large enterprise customers, they just want a way to embrace those trends without feeling like they've got to completely refactor, everything that they've, historically done. They want to grab onto those benefits too, but they want to do it in a way that's reasonably seamless and reasonably graceful. And, the metadata driven approach that we take, helps with that. And I think kind of increases our value proposition as, more and more of these technology trends, come on board. And as more and more customers realize that there isn't sort of one size fits all, that there's reasons why they're using data lake architectures. There's reasons why they're using cloud data warehouse architectures. There's reasons why, they want to do, some things in memory. There's reasons why they want to use different languages. That sometimes they want just sort of different levels of control over the manipulation of the data. So all of those things, I think, create really interesting moments, for us to jump in and, again, embrace those trends as they mainstream and provide a flexibility that, allows them to move across them without having to, completely rethink everything from the ground up each time a trend comes along. And as I talk to chief data officers and chief analytics officers and, others, they know that, I always ask them, I say, are the decisions you're making today the same as the ones you made 5 years ago? And the answer is no, usually. And so I'm like, okay, so it stands to reason that the decisions you're going to be making around data and analytics 5 years from now will probably be different again. And if that's the case, then you want to really think seriously about, future proofing wherever you can so that you're always, able to accelerate the work that you're doing.
In terms of the place that Trifacta sits in the overall landscape of data, I'm wondering if you can just give some context to that and some of the tools or systems that it might replace if you already have an existing data platform.
I like to describe what Trifacta does a little bit as the decoder ring for data, in the sense that we're not the underlying cloud data warehouse. We're not the BI tool. We're not the algorithmic, data science workbench. We're not the storage layer. We really do, kind of service this need of how do I, get data, into the right place? How do I cleanse, transform, and standardize it in a way that, kind of takes raw data and refines it to make it useful? And how do I make sure that that data then can be continually monitored and updated and delivered to the right places? So what we do is very much ETL, or I guess more accurately, ELT. The sort of how we do it, and therefore sort of the who we do it for, is what has been quite different. So for us, it's we profile data, we cleanse data, we transform data, we blend data. We do all the things that people kind of know and love about, traditional ETL tools, or in our case, ELT approaches. But everything for us is very much a very visual, very no-code, low-code experience where we apply a lot of the AI and the ML to the data wrangling process to infer things, to predictively suggest transformations. The nice part is, again, every data set's not a new data set. Odds are somebody has seen something like it before. As we now have, billions of examples of people transforming different kinds of data, we can curate that corpus of usage data at scale, and we can start to apply algorithms to say, hey, when people faced data that sort of was in this shape and size and format and had these kinds of problems, like, here are the kinds of things that they typically needed to do to the data. So we can provide those recommendations and suggestions. We can point out some of those potential issues and anomalies. We can help them remediate those challenges. And it really, a lot of it was born of this idea that, like, just take a data quality example. Like, what if your data set could actually suggest the quality problems that it potentially has to you, rather than you upfront guessing at those or trying to anticipate what those are? And so there are a lot of things you can do algorithmically now at scale that allow those kinds of things to be done much more predictively or done in a way that's much more automated. And so I think we get really excited about kind of taking that more traditional, kind of more legacy kind of ETL approach and trying to say like, okay, now on a modern stack in a modern way with all of the compute and algorithms and things we have available to us, as well as with all the advancements in user experience, like how can we come at this anew and really think about a guide and decide approach that will provide a more interactive experience for users and a more collaborative experience for technical and less technical people to come in and to do a lot of this work together, kind of building on the original concepts that were, the historical, kind of ETL concepts. And so I think, that's sort of the part of the stack that we inhabit. And, we can take it all the way from, connecting to systems and bringing data in to then doing all of the profiling, the cleansing, the transformation on the data, as well as then orchestrating the data flows and monitoring those data flows so that you can go from prototype to production all within the same environment and do it in a way that is very seamless and ultimately very user friendly. And we routinely will have customers that will, go from signing up for our trial to, getting to those data products they're creating or they're authoring, like literally in, sometimes in 15, 20 minutes, they've built stuff they're ready to kind of use in production.
And in terms of the actual platform, can you talk through how it's implemented and some of the architectural aspects that allow you to provide that seamless experience and just overall sort of design user experience of the system and how it's able to provide those experiences?
Yeah. So the first thing is it's a completely, SaaS-based solution, multi-tenanted, all of the benefits that you get from the elasticity, that high availability, et cetera, that one would expect from a traditional SaaS offering. And that allows us to do a lot of interesting things in terms of getting innovation to market very rapidly. So we're shipping, product, every couple weeks. It's a very dynamic and exciting environment. And a lot of that, came to us, and a lot of this sort of early architectural thinking around SaaS came to us because of work that we did in the early days with Google. So, Google came to us about 4 years ago and said, guys, we don't, have a proper data quality, data transformation solution for GCP. We have a lot of customers that are BigQuery customers and Google Dataflow customers that, are complaining that, if their data quality is bad, then, their analytics are probably worthless. So we got to solve this. And, we've actually never, resold or OEM'd a third-party technology on GCP before. They have a tendency to like to build their own stuff. But in this case, I think what Google has historically been great at are a lot of things that are engines and APIs. And this was, again, a very visual experience. And they just felt that, Trifacta had done something exceptional here. And so they, worked with us over the years to really build a very optimized service that would be able to handle, GCP scale and complexity. And then we subsequently stamped that out on Amazon and then eventually on Azure as well, so that we could provide a multi-cloud, story for customers that needed that to service different parts of the market. That for us was a way to make sure that what we were doing was going to, pass muster with, some of the largest organizations on the planet when it comes to, SaaS and cloud deployment. And that's everything from, security and, compliance and all the things that you have to pay attention to, in the SaaS world that are very specialized. But I think one of the things that also came out of that is with Google, you're dealing with, this is not a startup that gets to tiptoe into scale. Like, you're going to deal with Google scale immediately, and you're going to deal with global deployment immediately. In some sense, we get baptized in fire a little bit here, in the early days. And I think while dealing with some challenges associated with that, really hardened the product very early on. And so one of the things that came out of all this was something that we would describe as a sample to scale architecture. So you can imagine if you're trying to do all this in a browser in memory, then you better be really good at reaching into massive data lakes or into, massive BigQuery environments. And if you try to pull, many, many gigs, of that data back into a browser, good luck, right? There's no way that's going to be an eyes on data visual experience. Like, you're probably going to end up with a situation where performance becomes so painful, or the browser just crashes and you can't handle the data that you're trying to deal with. And so pretty quickly we said, we're going to need to build an in-memory technology based on WebAssembly that is going to allow a much larger samples. So we're going to have a sample for larger data sets. If we hit a certain threshold, we'll move to a sampling-based approach, and we'll be able to handle much larger samples interactively in the browser by essentially leveraging this modern browser technology in order to grab those much larger samples. But also, we're going to have to pair that with a much more sophisticated sampling approach, because it's not simply a matter of saying, well, let's just do a top of head sample or a random sample to get cracking. Like, you're going to need to support anomaly-based samples, stratified samples. I think we have something like 8 or 9 different sampling techniques that we support out of the box. And if customers have their own sampling techniques they want to use, they can essentially bring those and extend what we do. But this whole idea of, I want to do it interactively in the browser. I want to have eyes on data. I don't want to persist data on the desktop, but I want to make sure that I'm able to understand the nature and the complexity of the data that I'm dealing with, knowing that the data volumes could be, measured in terabytes or even petabytes in some cases, especially if it's machine generated data. And so that really informed our thinking from the very beginning as to, how to architect this solution, while still making it very visual and very interactive, and making sure that it was not a proprietary store that we were moving things into. We were not copying data everywhere. We were very sensitive to not just the egress costs, but the security implications of that, and wanted to make sure that, we could do that in a way that would perform and also be highly intuitive to the end user. And so that really dictated a lot of those early architecture decisions. And those were decisions that we made, in part in conjunction with Google as we rolled that out globally.
And in terms of the evolution of the platform, I'm curious, what are some of the aspects that have not really survived from when it, started in the early days to where it is now, particularly as you were dealing with that scale up with Google? And what are some of the sort of core elements that have maintained consistent throughout as you dealt with, this variety of scale, the proliferation of tools, the, number of different integration points that you had to deal with?
It's been interesting to see over the years. I mean, I would say a couple of things come to mind immediately. One is that when the company started, it was in the heyday of Hadoop. So everybody said Hadoop is going to be the analytic, platform of the future, and an entire tool chain was growing up around, because the traditional SQL-based and relational-based tools were not optimized for that level of scale and complexity for that platform more generally. And so, we kind of came into being kind of as that trend in the market was, moving at full force and speed. And so in the early days, we were generating, pig, and we were doing things from a compilation perspective on the back end that subsequently got supplanted by Spark, and then, subsequently then moved to SaaS and cloud, things like Databricks as an example. And so this, again, I guess goes to show you how quickly things do change, and why this polyglot architecture, from an engine perspective is so crucial, because, ultimately what we were doing initially in the Hadoop world, translated to kind of new languages and executions, but then also moved pretty dramatically from on-prem to cloud, and then subsequent to that, all of a sudden you saw the renaissance of SQL. And so very much started doing more work in and around SQL. And then, as we started doing more and more with data scientists who were saying like, hey, we hear our analytic engineers and our data engineers really like what Trifacta does. And now we're trying to figure out how we can spend more time on algorithms, less time munging data. Can we use it too? But they came and they showed up at the door saying, we really want Python, and pandas and Jupyter notebooks and things of that nature embraced more fully. And so you just sort of see these trends kind of come along. And in some cases, they place, prior approaches. In some cases, they're additive to prior approaches, because you're dealing with some different use cases and different personas. But I think we saw very much an evolution of, the engines that we were working with, and and therefore some of the languages and the compilation as we were generating code that we were dealing with along the way. I would say probably the second area that we saw that where our thinking evolved was very much in and around connectivity. I think in the beginning, we said, well, gee, a lot of the ingestion or the data movement, the sort of E and the L of the ETL process has been, broadly commoditized. A lot of the open source guys are giving that away for free. The cloud guys are giving that away for free. Scoop, Flume, Kafka, FTP, traditional ETL, however you get it there, by hook or by crook, you're going to get the data into the data lake or into the cloud. And we said, we're going to really focus on the T. And so we were this kind of strange animal that was, essentially an ETL company that didn't do E or L. We just did T. And we did T in a very different way. But that's really where we put all of our energy because we thought all the value was in the cleansing and the transformation and the profiling. And that's where you were going to win the hearts and minds of the users. And so we left all the other stuff to other people. The big lesson learned, though, was that if the data is not in these modern platforms, then you get stuck and they never get to your goodness. And I guess the other thing you learn is that if you're pitching self-service, if you're really trying to say like, hey, we're going to democratize, this, then, sure, there's other ways they could get the data there. But in the end, they're like, if you're a self-service solution, then be fully self-service. Like, don't tell me that I need to go off and talk to 10 other people in order to get to a point where I can self-serve, or don't tell me I have to go use 5 or 6 other tools before I can self-serve. Like, the whole point is you're supposed to be taking out friction and pain. And right now, if you only do the T, then you're not helping me service enough of my end-to-end problem. And sometimes getting the data where I can operate on it is not just the beginning of the problem, but in some cases can be one of the bigger challenges. And so we've added a tremendous amount of, I think we support now over 200 adapters, and there's a connectivity framework where you can bring your own adapters or roll your own if we don't support them. There's a lot that we've done to try to solve more of the data movement challenges as well to complement what we've done, because we want to get to a point where people can sort of do this on their own without it turning into a project that requires lots of other dependencies throughout an organization, which inevitably slows things down and makes it difficult to get to value quickly. So those would probably be 2 examples of how the technology trends have evolved, but also how our thinking has evolved, over the last 8 or 9 years as we've gotten into more customer scenarios and as we've kind of seen what the market, wants from us.
For somebody who's using the Trifacta platform, can you just talk through some of the overall user experience and workflow of going from, I have this problem, I need to be able to build some sort of analysis, to I have processed the data, I've cleaned it, I have built my analysis, and just the different touch points and the different roles and responsibilities that are interacting with this platform throughout that process?
Maybe a good way to describe that is to just give you an example of one of our customers and how they use us. So GlaxoSmithKline is a customer that's been with us for a number of years. This was pre-pandemic, but even then they were very focused on how do I use data to speed the process for the approval of new drugs? Because right now, from inception of a new drug to FDA approval, process is like a decade. And they're like, we think that with better data and proved ability to work with that data, that we could at least cut that in half, right? So this was pre-COVID, where people are trying to figure out how they can get this done in a year or 2, when they were like, ambition was like, let's get it from 10 years down to 4 or 5 years. Kind of first best example of that for them was in the area of respiratory drugs. So, they have a big business around things like asthma, and so they sell a lot of inhalers. And, when they would do clinical trials with these inhalers, they'd send them out and people use them, and then they'd ask them to fill out surveys. And it's like, did you use your inhaler, 3 times a day? Did you use 3 pumps each time? Did you use it at 9, noon, and 5? And, they would get information back. But, sometimes people didn't know they weren't using it correctly. Sometimes they didn't remember exactly how they used it. And so there was a lot of noise, in the data. So at some point, they decided to put sensors into the inhalers, and they were going to then get behavior data. So what they called real world evidence that would help them get more accurate reads of what was going on as they were doing these clinical trials. Now, the challenge with that, though, is that now you've all of a sudden got this new sort of data type that you're dealing with, which, was different than the experiment data, the assay data, the medical record data, all of the other things that they were trying to stitch together to do the work. And they wanted their scientists to do it, not necessarily data scientists. These were more like chemists because they knew what the codes meant and they knew kind of what they were looking for. Again, context in their heads. And so they said, well, we're going to get this to a point where they can go in and do a lot of the data manipulation on their own. And we think that that is, again, going to help, speed up the process to understand efficacy of new drugs, understanding, things like contraindications, et cetera, and doing the analysis they need to do for the FDA approvals to get through the stage gate process. And so, we became the piece of the puzzle that, was, helping them to take this disparate data that was coming from a multitude of different systems. We were helping them to land that data in a data lake. We were then helping their scientists, their chemists, get access to that information, get eyes on that information, and do a lot of the cleanup that they needed to do, to file the appropriate, trial findings with the FDA and to feed that back into the process of the research that they were doing. The last mile visualization was being done, some of it was literally Excel spreadsheets, some of it was in things like Tableau, some of it was more statistical analysis that they were using SPSS and other technologies or other, kind of BI reporting, analytic, and algorithmic environments for. And so again, from our standpoint, since we're not trying to be that end of the equation, we want to prepare the data or refine the data so that regardless of what end user tool you want to do for the analysis, it's always in a form that you can grab onto it that's useful. It's also governed so that if you ever have to show your work, like how did you get that data in that format, you'd be able to do that very cleanly, right? And I think that sort of audit trail or lineage also becomes really important, to making sure that, again, the self-service aspect of this thing doesn't, go off the rails.
Are you bored with writing scripts to move data into SaaS tools like Salesforce, Marketo, or Facebook Ads? High Touch is the easiest way to sync data into the platforms that your business teams rely on. The data you're looking for is already in your data warehouse and BI tools. Connect your warehouse to High Touch, paste a SQL query, and use their visual mapper to specify how data should appear in your SaaS systems. No more scripts, just SQL. Supercharge your business teams with customer data using High Touch for reverse ETL today. Get started for free at dataengineeringpodcast.com/hightouch. One of the things that is often interesting to think about as you're working with these self-service tools where the target end user is an analyst or a domain expert who doesn't necessarily have all of the context that a data engineer might have about how best to structure the data, make it reusable, make it organized. It can sometimes lead to, data sprawl, where if a data engineer were to build the system from scratch, it's going to be less accessible to the end user, but it might be more, internally cohesive. And I'm curious how you're able to balance those tensions of wanting to make something accessible to the end user, but well organized and maintainable, and any interfaces or patterns or systems that you provide to the data engineering team to be able to enforce some of this internal structure and collaborate with the end users to help educate them about how best to access and process the data.
What you just described was the lightning bolt like moment that I had pretty early on in my tenure at Trifacta. So, I wasn't a founder. I came in as CEO after the company had been up and running for, 2.5 years. And one of my first presentations was to Bank of America. I was presenting Trifacta to a group of executives that had come out to California for an innovation summit. And I presented, it was only a few weeks into the job, very passionate about this exciting new technology, and, got done. And I was like, wow, that went really well. And I felt really good about it. And one of the executives came up to me and was like, wow, that was a great, presentation, super exciting stuff you guys are doing. I was feeling the momentum. And then that same executive said, but we're never going to buy your product. And I was like completely crushed. And I was just trying to think to myself, I was like, listen, I knew this guy, from my time at Informatica, and I grabbed him. I said, please come to the bar. Let me buy you this was in the afternoon. I'm like, let me buy you a drink. And in the time it takes you to have that drink, pound on me and tell me what we got wrong. And so basically it was a lot of what you were describing, which is like, hey, what you guys are trying to do, we agree that data products are going to be the frontier for competition, that it's less just about the algorithms and about the infrastructure because it's in the open source community. You can spin up new environments with the click of a button. It really does now come down to like, how quickly and productively can you stitch new and interesting data sets together in new and interesting ways to yield new and interesting insights? So we're like, we get that. And we love the idea that we're going to almost start to crowdsource some of these data products, from this broader set of users that are kind of out in the organization. But they're like, but we are a highly regulated bank and we are hundreds of thousands of people. And if you guys don't really think through very carefully how that stuff is going to be organized, how it's going to be shared, how it's going to be reused, how it's going to be kind of managed, then we can't afford to bring you in, because this will, sort of die under the weight of the organization, or it will, lead us into a sprawling situation that, starts to get out of control if it's successful. So I was like, okay, well, what does this mean, right? And they said, well, you got to think about, the things that the data engineers really care about. And again, this was part of our transformation from like really thinking about this kind of collaboration rather than just the initial genesis of the company of like, let's go focus on what the analyst wants. Then now we were starting to say like, okay, we really got to care about what the data engineer wants. And we got to start thinking about the pipelines that created. How are we going to monitor those pipelines? And we got to start thinking about the SDLC process and like, how are we going to essentially integrate with stuff like Git and allow, recipes and code to be checked in and checked out and sort of managed and versioned correctly? How are we going to, think about templatizing things so that, if there are well-worn paths for doing certain types of work, that you can grab onto templates and you can use those? How do we start thinking about macros? How do we start thinking about approval processes where if somebody is collaborating on a recipe, that there may be certain steps where you have to check with somebody, as part of implementing something, where a subject matter expert could sort of put their seal of approval on something before the concrete gets poured. We have to think about chain of custody of the data. Like, can you go in and literally every single step of every recipe and every edit, when it was made, who it was made by, so that if somebody ever says like, if we're doing, well, and, this is true for what we did at Bank of America. It's like, if you're in the quant group and you want to know like, okay, we built a training data set that ultimately birthed an algorithm that we then tried to trade on. At some point, someone would say, well, then how did you create that training data set? Because now we're making multi-million-dollar trading decisions, right? So it's like you needed to like really just grapple with all of that in a pretty profound way. And it completely changed our focus and investment strategy over the last, probably 5-6 years to grab on and embrace that more fully. And so that became a very powerful lesson. And the epilogue to the story is that now Bank of America is one of our largest lifetime value customers. But it sort of went from that moment of, kind of being punched in the gut a little bit and saying like, hey, this is cool, but if you haven't thought about this other half of the equation, then, this is a non-starter for us.
And then another element of the solution that you're providing, and you touched on this a little bit with your discussion about the different sampling strategies, is the limits of scale or complexity that your end users are able to tackle using Trifacta, just because of the fact that at a certain point, if you don't have a large enough sample size or because there's enough variation in the data, you're not going to be able to produce a truly effective recipe for processing and cleaning the information. And just some of the strategies that you and your customers have come up with for being able to deal with some of these limits of scale, whether it's, one of the 3 V's of, velocity, volume, or variety, and being able to pre-process and clean and pre-aggregate the data before exposing it to the end users in Trifacta.
The scale question comes up a lot. And, I think part of it is because the world has gotten to a point where, they want a spreadsheet-like experience, but they understand the limits of spreadsheets, both in terms of the data types it can handle as well as in terms of the volume that it can contend with. It was very interesting for us to try to, think about, like, again, from the very early days, like how to solve that problem, in part because, data lakes were kind of our beachhead in the beginning. So we, in some respect, picked a tough beachhead because it wasn't like, most companies probably would have started smaller data sets, less complicated situations. Like we immediately went in and said, we're going to do this on some of the biggest data lakes in the world. And that, of course, then led us to some of the biggest companies in the world. And so then next thing you know, like you're not easing into this, like you're having to solve these really big, complicated architectural problems right up front, which is kind of daunting and, pretty capital intensive as well. Like I needed to hire up a bunch of people who came with, down in the dirt experience of having built scalable systems for big enterprises, who could bring that mentality in, while at the same time we were trying to be this like disruptive young company that was applying like kind of new approaches to, visualization on data and kind of applying ML and AI to the data to automate things. And so it was like kind of a marrying of like, people that we were hiring out of like LinkedIn and Facebook with like people that I was also bringing in from places like Informatica. That was an interesting kind of cultural experience for us to go through. But yeah, that like truly trying to go after that and to sort of think through like how we're going to do that, became a key differentiator for us. And it's a lot of, hard lessons learned as you get into these big projects and you see the scale of the volume that the data has. And I think, to your question from earlier, it's like one of the other things we learned, though, is that at some point people also wanted different almost zoom levels on the data. And so we took very much, again, this spreadsheet style metaphor, but we were doing everything behind the scenes that was more of a push down operation into these various engines. That's where we could get the scale. And we got good at the sampling and we got good at this sort of in-memory work that we were doing in the browser and the interactivity and all of that. But then some people said, well, hey, but I still want to be able to zoom back and almost take a more process-centric view to what's going on with my data. And so then we said, oh, okay. So we created something we call the flow view, which would be probably more typical of a traditional ETL kind of mapping, kind of view of the data. And then as we started doing more work with the data engineers, they're like, well, this is a long tail market, right? Like there's a lot of data complexity out there. And as much as what you're providing visually is awesome, there are always going to be some corner cases where there's some weirdness in the data or there's something going on in the underlying systems that you need to be able to handle that may not be a first-class feature in Trifacta. And we can't have your roadmap prevent us from getting those use cases done. So that's when we introduced this idea of more of a code-centric view, where if you really need to drop down and write a little bit of code, you can do that, because there may be things that we couldn't have anticipated, or maybe we've anticipated them, we just haven't been able to get to them. And we don't want the answer to be no, we want the answer to be here's how. And that's where, user-defined functions and pre and post processing and parameterization and like all kinds of capabilities come out of that give people the ability to, the more technical users, the more the traditional data engineering audience, to go in and actually, kind of help contend with that scale and complexity that inevitably exists, in the exotic world of like all this data coming together and, from all these different systems, and this voracious appetite for people to stitch it together in unique ways.
And as you have been working with Trifacta and growing the business and working with your customers, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
There was a Center for Disease Control case that I was fascinated by. So there was a number of years ago, you may have heard of this. There was an article, I think it was in the New York Times, that was about an outbreak of HIV in rural Indiana. And the CDC got involved because they were just trying to figure out, like, what the heck is going on? Like, this is very strange that we're seeing this like hot, it wasn't a pandemic, but a sort of epidemic localized to this specific region, this outbreak. And, they have essentially data black belts, right, that bomb in, and their job is to like try to understand what's going on. And a lot of that is, you're looking at, geospatial data, you're looking at to see where things are going, you're looking at all kinds of research, you're looking at medical like data from the hospitals that's coming back, you're looking at police blotter, or police record data, you're looking at demographic data. The list goes on and on and on, because you're just trying to piece together a narrative on like diagnosing like what is happening and why is it happening here of all places. These are very urban, issues, and all of a sudden it's like in the middle of this, relatively small town. And, eventually you start to see, kind of a picture comes into view where looking at all this data, and keep in mind that like when people are dealing with some of these types of situations that have social stigma attached to them, it's like if you're showing up at a hospital, you may not be using your real name, right? There's things people are doing to try to like hide data or to make sure data is not so easily found or interpreted because of the circumstances. And so anyway, so it just makes that challenge even harder. Well, they were able to, use Trifacta to really start to put together a narrative on what was happening. And as it turned out, like by looking at all of the trends and the analysis and patterns and what they were seeing is that, with the continued gentrification of certain parts of Chicago, it was forcing, people to move further and further into the suburbs, in some cases into these small towns. In Indiana, they were starting to bring then some of the urban problems with them. A lot of these smaller towns were ill-equipped in terms of, needle exchanges and, condoms, because things like prostitution and other things started to become a little bit more prevalent. And so all of a sudden you started to like see what was happening here. And then you could go in and try to remediate this before it becomes, through education and through other mechanisms before it becomes, too much of an issue and sort of spreads even further and further into farther flowing regions of the state. And so that was for me like a really amazing story of, how data is like, being used, broadly for social impact. And also, I think a recognition of just how hard it was to get all of that data, which frankly was more about the diversity of the data than the scale. It wasn't that the volumes, you weren't dealing with, terabytes of data. You were dealing with lots of small data in lots of crazy formats with lots of quality problems, like a lot of sparse data, a lot of data that was anomalous in different ways that ultimately, had to be brought together to like tell this story and to get to some conclusion and then ultimately, a diagnosis and a remedy, for the issues they were seeing. And to me, just a great example of the impact that platforms like Trifacta can have on, speeding up that time where, minutes and days matter, when you're dealing with something like HIV and something like an epidemic in a specific, part of the country.
Yeah, it's definitely a pretty wild story. In terms of your experiences of being the CEO at Trifacta, and particularly somebody who wasn't part of the founding team, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of coming into the company and helping to grow it to where it is today?
I guess my entry was pretty straightforward in that, I came in with a lot of domain expertise. Even a number of the people on the team, from day one, I was able to have immediate impact because I could bring my network to bear very quickly on, both acquiring customers as well as building out the organization. So a lot of those things were actually pretty straightforward for me. It also helped that the co-founder, Joe Hellerstein, who was the CEO before me, who's now currently our chief strategy officer, he said from day one, he's like, I'm a professor, and at some point this is going to become as much about commerce as it is about technology. And that's the point at which, I'm going to need to take a different role here and probably go back to teaching part-time and working here part-time. And so he made that pretty clear to all the investors and the employees from the beginning that he was not going to be the long-term CEO of the company, that there would be a managed transition, when the timing was right. And there were no big surprises there when that happened. And I think that was, very, mature of him in the sense that, he kind of recognized what he wanted to do, what he felt he was good at, where he thought he could have value. And sometimes you have founders who want to hold on at all costs, no matter how, the world changes around them or what they're sort of best at. And there was none of that succession challenge, between me and Joe, and we've been great collaborators ever since. So I think that part of it was really great. But I think the fact that was set up that way from the beginning, it was a good lesson, to me, and thinking through succession planning and thinking through how stuff gets communicated, thinking through how you set expectations around that, thinking through bench strength and, all the different areas that you're coming to depend on. So that was, I certainly think, a good experience and a good set of lessons learned. Sort of beyond that, in terms of my arrival, the thing that I find is you got to hold in your head simultaneously, is that you got to be all about alignment and focus, but then at the same time, you also have to be adaptable. And those things tend to push and pull on each other in ways that create a lot of tension. I think back to when we started and it was, on-prem data lakes kind of roamed the earth. And then all of a sudden, cloud came in and cloud data warehouses, and it became as much about, SQL and cloud as it was about things like Spark and on-prem data lakes. And things shifted, pretty fast. And so on the one hand, you have to be really focused on what you're doing, because I'm a big believer that, indigestion kills most small companies more than starvation, and you just have to keep everybody rowing in the same direction. And, we have been pretty maniacally focused on the same thing since the beginning, this vision around, self-service, and this vision around user experience and machine learning informing that, and just staying focused on the data prep pieces and on the ETL, ELT pieces. In the past, people have said, well, why don't you go do an analytic workbench? Why don't you go do BI? Why don't you go be a catalog? Why don't you go do all these other things? And we've generally said, no, in part because of focus, in part because we don't want to dynamite our ecosystem of partners that bring us into opportunities or that we work with in implementations. But, things do change, pretty quickly in this world. And so as much as you have to be crazy focused, you also still have to make sure that you don't miss these secular shifts that happen. And it feels like they're speeding up these days. And so all of a sudden, when it became about SaaS, we had to burn the boats and be about SaaS. And all of a sudden, when there was this SQL renaissance with, cloud data warehouses, which, analytics were very stubbornly an on-prem thing up until, I'd probably say 18 to 24 months ago. It's not even that long ago. But with the rise of, things like BigQuery and Snowflake and others, now all of a sudden people seem, way more comfortable doing, their analytic work, in the cloud. Whereas, applications had gone cloud, a decade ago. DevOps went cloud a long time ago. But analytics was, again, still very stubbornly on-prem. And then boom, the bit flipped. And when that happened, you don't want to be on the wrong side of that trend. So, it is this sort of all this constant tension of alignment and adaptability. And you kind of have to charge hard at the thing and get everybody 100% focused on the thing until it's not the thing. And then you got to shift, and you got to shift fast and aggressively. Otherwise, you miss these trends. And so I think that, for me has been both the really exciting part of this job. It's also sometimes a little bit the nauseating part of this job. but in the end, I think that's what you sign up for, when you're an entrepreneur, and that's what you sign up for when you work in technology. And increasingly, that's what you're signing up for when you're in data and analytics.
And for people who are dealing with trying to get their data into a usable shape, or they're trying to democratize access to it, what are the cases where a Trifacta is the wrong choice?
What I would say is, there are certainly, cases where people are, focused on things like streaming. That's not a focus for us today. That at some point, logically, it would make sense that we'll get more into doing work with streaming data. But, we tend to operate on data that's landed somewhere. We tend to be batch or micro batch. So you can run it every few minutes if you want, but we're not transforming data in stream. There's definitely hardcore replication, change data capture style use cases that it's not streaming data, but, a similar ilk in terms of, kind of more sophisticated replication that is not what our focus is. There are, definitely cases where people just, for a variety of reasons, want a code first or code only solution for how they're going to do this work. And while we are embracing code more and more every day in terms of Python and JavaScript and SQL, and providing, again, opportunities to put code into Trifacta at different levels and in different places, there are cases where, if it really is we just want to write a bunch of Python, it may not be the best fit for us. Certainly, there are cases where people want to write a lot of code who still want our profiling and still want some of our orchestration and other things that we do. They don't want to have to write all the code. They just want to write some of the code, and that's fine. But, I would say those are a couple, cases that come to mind. And then the other things that I mentioned, which is sometimes people get confused around, because we're so visual, they think, oh, well, maybe Trifacta could be my dashboard or my sort of BI, solution, or my reporting solution. Again, while we take a very visual approach, it's visualization in the service of cleansing and transformation of data. It's not visualization, for the purposes of end user, downstream consumption in that regard. So I think we try to be pretty careful, not to position where a Click, a Tableau, Power BI, a Sisense, a ThoughtSpot, or somebody would play.
And as you continue to lead the company and explore the constantly emerging trends in the data ecosystem, what are some of the things that you have planned for the near to medium term of Trifacta?
A lot. So I think we're spending a lot of time right now doing what you mentioned DBT earlier and earlier. We're doing a lot of work in and around DBT. So we've got some of that is in private preview right now, but you'll see some announcements from us around the work that we're doing. It's a great open source project that the community is really grabbing onto, and we think we've got a role to play in that story. Stay tuned for that. A year ago, we added a lot of capability in our optimizer to think a lot about where to run certain things. So doing certain types of push down based on what was going on in the different sources and targets. More recently with Google, we announced, full compilation to SQL where BigQuery would be the engine. And we would actually run everything inside of BigQuery. And you're going to see us do more of that with more of the cloud data warehouses where it's not just doing kind of partial push down, into different engines, but literally full compilation, leveraging those engines as the engine. And the cost and performance characteristics we're getting out of that, if that's where your data lives, is just massive. So that's been super, super exciting. Continuing to, build out what we call the developer experience story. So doing more and more to facilitate the things that the data engineering crowd, is pushing us on, with integrations to, Airflow and Git and, all the things sort of in and around that. We've done some of that to date. We're going to keep doing more and more. We're continuing to optimize, how we tie into the rest of the tool chain that the data engineering community is focused on. Those are some of the chunkier areas. Also doing more around monitoring drift, providing a lot of intelligence on how to handle drift, through some of the pipelining things that we're doing. Those are all, pretty, significant areas of investment for us. So,
are there any other aspects of the Trifacta platform and the work that you're doing or the overall place that it has in the landscape of data that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered a lot of it. Maybe the other thing that we didn't get into, which is a little less about the technology, but more about the business model for us, is that, we've also moved to a completely usage-based model. So we were always a subscription service, but, we've really moved to more usage-based because it's important to us not just to democratize the actual production of the data products, but to actually have a model for pricing and packaging that can be democratized as well. So it doesn't do any good to say, we're all about democratization and then, somebody's going to charge you, $10,000 a seat or, charge you some huge, platform fee in order to get started. We think that, the Trifacta, you can get started for free. The first tier is, $80 a month. And we want to make it really accessible to a broad range of users, a broad range of use cases, a broad range of different types of companies. And, we think that's really important, so I think that's probably something that gets less focus, but ultimately that business model has to be coherent, your technology story with kind of your go-to-market strategy. And so we've put a lot of effort into, refining that over the last, couple years, as we've started to see more and more users come to us that are not just in the big, banks and insurance companies and pharmaceutical companies, but as we're seeing more digital native companies, as we're seeing more startups, as we're seeing, companies that are in the mid-market, that are doing often really exciting, really sophisticated things with data, but at the end of the day, need something that's kind of right-sized to, what they can afford to roll out, and often don't have big IT organizations that can take on massive projects, but really need something that is, completely integrated, from an experience perspective.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
And this probably relates a little bit to our investment thesis, but, we keep hearing from customers that the data quality piece in general still does not get enough attention. And I think that people are terrified that as you start talking about more automation, right? So, whether it's kind of robotic process automation or whether it's just more algorithmic decision making that's going to start happening in an automated way, that people are terrified that we may start automating bad decisions faster based on bad data. And this has us like, I always tell the team, I'm like, we can't invest enough in the data quality capabilities of the platform, because every time we come out with something, it is like off the charts used immediately. And so you're hearing a lot more about, maybe a more modern spin on it around observability. I think that certainly is one aspect of all of this. But, I would just say that, forever, this has been a constant challenge for a lot of organizations. People have lamented the fact that their data quality is not great. And, I keep hearing from executives now, and even from the data engineers that we work with, that they want to take this moment in time, as the burning platform to like go fix some of those data quality problems and to get good at identifying them and remediating them. Because, the logical conclusion of this is that, you're going to have to start finding, needles in the haystack when the haystacks are coming at you faster and faster. And where a lot of what's happening, based on that is getting more and more automated. And so it just is both a bigger opportunity, but also a bigger threat if it's not done right. So I guess that for me is probably the one that sticks out the most.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Trifacta. It's definitely a very interesting platform and an interesting approach to the overall problem of dealing with messy data. So appreciate all the time and effort that you and your team are putting into that. And I hope you enjoy the rest of your day.
Yeah, Tobias, thank you so much for having me. It's been a lot of fun.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.